Hello everyone, in this video we're going to learn how to find the sinusoidal regression with TI-NSpire and TI-84 calculators and answer the question that related to sinusoidal regression. Alright, so we're going to bring up the TI-NSpire calculator. Now we're going to hit doc, number 4 insert, and number 6 list and spreadsheet. Now we're going to input the values. The left hand side should be the t values, the right hand side should be the high values, right? Alright, so I will finish inputting the values for the table. Now remember that the left one is the column A, the right one is the column B, right? Alright, so I'm going to hit menu, number 4 statistics, number 1 start calculation. Now I need to find the sinusoidal regression. So basically, I'm going to go down. It's going to be right here, sinusoidal regression C right here. So I'm going to hit this one. Now, S list, which is the A column, so I put A. Y list, which is the B column, right? Alright, so right here, the Y list, you need to hit Control, open parentheses to find the bracket. Alright, it's going to be right here. Now remember that the calculator store your regression as f of 1, right? So iteration right here, the more the accurate, so I put h right here. You can put 16. Alright, so go down. Your results will be stored at the column D, right? So I'm going to hit OK. So I'm going to write down the answer for question A. Alright, now let's move on to question B. Based on the sinusoidal model, predict the high altitude water at 7 p.m. to the nearest 10 of foot. Alright, so 7 p.m. which means t equals 19, right? So this one, t equals 19. Alright, so we're gonna hit doc again, insert for right here, graphs. Alright, so this is a function f of 2. Now remember f of 1, which is the sinusoidal regression. So we're gonna hit upper arrow right here. We get f of 1 right here, and we hit enter. So we see the graph right here. Now the graph doesn't show up completely because of the window range. So we need to limit the window range from 0 to 24. Right, so we hit menu, window, zoom right here, and window settings right here. Now S min should be 0, right? And S max should be 24. Then you're gonna hit OK. So here's the graph that has the domain from 0 to 24, right? So now we need to find the value of the height of the water at t equals 19, right? So we're gonna hit menu, hit number 5 right here, trace, graph trace right here. Alright, so we just input the 19, right? And then we hit enter. So the value should be 1.11. So at t equals 19 or 7 p.m., the height of the water is 1.11 feet, right? Now, the question asks us to route to the nearest 10 of a foot, right? So the answer must be 1.1. There is another way to predict the height of the water at t equals 19 without using the graph right here. Remember that you store the function as f of 1, right? So you hit Control I, hit calculator, and then hit vars f of 1 right here. And then you just hit 19, close parenthesis, and hit enter. So it gives you 1.1, right? Now let's move on to question C. Is it safe for a certain type of boat to leave the bay only when the water level exceeds 2 feet? Based on the sinusoidal function found in part A, on what time intervals is it safe for this type of boat to exit the bay? Alright, so we're gonna go back to the graph right here. Now we hit tab to put the second equation should be 2, right? So we put 2 and we hit graph, right? So we hit enter, and then it's gonna be right here. Now we need to find the intersection between two graphs right here, and remember that the level of the water should be above the lines right here, right? So which is the curve right here. Alright, so we need to find the intersection. Now we hit menu, number 8 geometry, number 1 points and lines, and number 4 intersections points right here. Now we hit the first graph and then the second graph. It gives us the two intersection points right here. Alright, so we just copy this one down, and this is actually the interval. Now the second method, I'm going to use the TI-84 plus E calculator. So I'm going to print up the calculator right here. What you're going to do is to hit start, edit. Now you need to input the value for this table. Next, you're going to hit start again, go to count, go up, and then you will see sign regression. Hit enter. Now, iteration we put 3, as list we put L1, while list we put L2, period right here, we look at this, the value of t right here, put 24, right? So right here we put 24, and then we need to store regression, so we hit vars, y-vars, function, y1, and hit calculate. So your answer right here is exactly this guy right here. Alright, so now we want to see how the graph looks like. We just hit second, start plot, and we hit enter, on, turn this one on, and we hit graph, and it's gonna be like this. Now we need to adjust the window to see the graph. So S min should be 0, S max should be 24. Right, the scale is 1. Now Y min should be 0 and max should be 4, right? And then the scale right here, you just put 0.1 and hit enter, and the graph should be like this. Alright, so based on the sinusoidal model, predict the height of the water at t equal 19, right? 7 p.m. which means t equal 19. Right, you hit second trace value right here, hit enter, and then put 19 and hit enter. The answer is 1.1 right here. Alright, now question C, we need to sketch the graph y equals 2, so we hit y equals. Now the second graph right here, we put 2 and we hit graph, and we see that 2 graph intersect at this guy and this guy, right? Now we need to find the intersection between two graphs right here, right? The first intersection right here, so we hit second choice, number 5 intersection, and then we hit enter 3 times, 1, 2, 3. And then the first intersection right here is going to be 3.4, s equal 3.4 is going to be right here. Now you hit second choice again, number 5 intersection. Now you go to the right here, hit enter 3 times, 1, 2, 3. So it's going to be 14.9, so it's going to be right here, and it's the time to stop. Thank you for watching. I hope you enjoyed the video. Remember that if you failing to prepare, you're preparing to fail.
We rise like tall buildings as the chemicals, they take us higher. The night's young and it's just begun as she puts her hand